Technology GM, Mr. Xu Baoqiang. He's also very young, born after 1980. So we know that the intelligent technology is embracing a very good period. And we are also very glad to have the iSoft infrastructure software Vice General Manager and the head of the research institution, Mr. Zhang Xiaoxian. He is now working on the open source system development, and he also will share with us their updates. So we still remember that the year before last year, Chairman Wang Gang and Mr. Zhu, in the discussion, Minister Wang Gang asked that for the ICV development, we need to further develop our fundamental software, and we also need a good foundation for the future development, and we hope to sustain in the wave of anti-globalization. So iSoft is working on this critical foundation infrastructure, and I look forward to your sharing. We're also very glad to have a new Shanghai CTO and President, Mr. Du Qiang. Mr. Du Qiang is also quite young. So we see that for the science and technology company leaders, they are either CTO or the Chief Marketing Officer. And I believe he will also give us a wonderful sharing. And also, we have SI Engine Vice President and General Manager of the Product Planning, Mr. Jiang Hanping. The SI Engine chip technology is quite advanced. It also has its unique architecture. I look forward to your sharing and introduction. This is different from the traditional chips. And also, Chang'an Auto Chief Engineer, Mr. Su Ling. Because Chang'an Auto is a chief supplier for the critical components for the most advanced vehicles. And this is with very high technology value. And they are also quite open, supplying Chang'an Auto. And another 50% of the product is provided to the other automakers in the market. And let's put our hands together to thank all of our guests. Thank you very much. And I believe that you're also looking forward to the presentations. So without overdue, I would like to give the floor to the Technical Director of International Organization of Motor Vehicle Manufacturers, Mr. Oliver. So if you need simultaneous interpreting, you can please feel free to get the headset.
Thank you very much, Mr. President Fu. I'm very honored and very pleased to be here today. Thank you very much for this invitation. I'm also quite impressed by the quality of the other speakers, so I will try to be at the right level. So my presentation is about the beauty and the benefits of the regulation harmonization, so the worldwide regulation for the automotive industry. So first, maybe a summary of what I would say there will be 3 parts in my presentation. So first I will explain a little bit what is OICA, because maybe not everybody here knows the OICA. Then the role of the regulation and the harmonization of the regulations worldwide. And then I will try to convey key messages to the audience today. So first, what is OICA? OICA is the International Organization of Motor Vehicle Manufacturers. So OICA is the French acronym for this title. So we are a world federation, so our members are the national federations, like CAM here in China, JAMA in Japan, SMMT in the UK. We have 35 members throughout all the continents, from South America, from South Africa, North America, Europe, of course, Asia. So and CAM is one of the 35 members. All major manufacturers are present as, I mean, indirectly via the national federation. And as it was said in the introduction, OICA is the unique non-governmental organization having the mandate or the accreditation to represent the automotive industry in the world, automotive industry at the United Nations. So OICA is the voice speaking on automotive issues in world forums. Now, what are the main activities of OICA? First, we develop, that's maybe the main activity, that's maybe 90% of the activities of OICA for the moment. We develop some international regulations at the United Nations. We also are quite active in releasing some statistics figures. We organize the auto shows worldwide, and we develop some position papers, like I give two examples. For example, the white paper on the decarbonization, and also we developed a charter for the use of the good fuels. We also developed what we call the manifesto, providing the minimum requirements that we would like the manufacturers to respect worldwide. But the main activity is at the regulation point of view. So the structure of OICA, so as I said, we have 35 members, including CAM. They are coming from all the countries, USA, Korea, China, Belgium, little country, the UK, and all the others worldwide. The work we do at the United Nations is at the UNECE, so the economical, the European Commission for Economic, the United Nations. And just to show you the structure of the technical committee at OICA, we actually mirror the structure that exists at the United Nations. So you see on the left side of the column the structure at W39 at the United Nations, where we have 6 subgroups. And we at OICA, on the right side, you see that we have the technical committee, and that is mirroring all the subgroups that exist at the United Nations. Of course, all of these small groups have subgroups as well. So there are maybe 100 different task forces, special interest groups, etc. Where we are together with all the experts coming from the manufacturers, we are active at the United Nations. So what did we already achieve? What were the targets that we reached already now? We developed some regulations that are worldwide harmonized on passive safety, so the seatbelt, the crashworthiness, frontal impact, side impact, some active safety regulations, so anti-lock system, stability control system, automated emergency braking system, lane keep assist system, etc. All those regulations are worldwide harmonized, so you can develop those systems once and send them all around the world. About pollutant emissions, so the WLTP, you maybe have already heard about that. The real driving emission, and there is more to come on CO2 emissions. We developed some regulations for the electric vehicles, for the fuel cell vehicles, and now since 2019 we have developed and adopted some regulations about the connected vehicles, so the cybersecurity, the software updates, and we are still maintaining those regulations. Now, what happened for the ICV, for the automated vehicles? How can we implement them on the street in a safe way? Actually, so the good news of the day, is that we have a solution. The solution is the combination of the construction regulations and the traffic rules. The construction regulations are developed at the WP29, and them, together with the traffic rules that govern the behavior of the vehicle on the road, together, the combination of the two permits to have a safe deployment of the ICV on the road. And that's being developed at the United Nations. Now, we arrive to the second part of the presentation, where we talk about the role of the regulation and what we mean by the harmonization of the regulation. So you see those two little vehicles. They would like to enter the Japanese market. They would like to enter the the USA market, the Korean market, the Chinese market, and maybe the European 27 countries, the Russian market, and others. And they are wondering, how can I adapt myself to enter those markets? And the problem is that we have a kind of fragmentation of the market, because the vehicles may be different for entering each of the markets. And this market fragmentation is detrimental to all, to the national authorities first, because they would like to know what vehicles they accept in their own territory. The manufacturers, that means ourselves, because we have to develop a vehicle different for each of the markets. I'm talking about maybe 40 or 50 different countries. So it's, of course, expensive for us, and for the final users, because they will have to pay for the additional cost for the manufacturers. Now, the solution to that is the United Nations, where at WP29 we have developed the forum for the harmonization of the regulation that permits the manufacturers to sell the same vehicle, or for the suppliers the same system, like the braking system or the steering system, worldwide with no change. So how does that work? Actually, the United Nations is a kind of supermarket of the regulation. So you see this little man here on the picture represents a country, and that country would like to have a batch of regulation, for example, for the ICV, for the automated vehicles. And so that country wonders where can I find the proper regulation. So they go to the United Nations, they select the proper batch of regulations, and they just take them to make them applied mandatory on the territory. And there are two comments to do that. First of all, it's for free, because the work is done at the United Nations by all the experts. Somehow, the United Nations are totally open to everyone. That's the beauty of the United Nations. So you don't have to pay to get those standards. When I say you, I mean the country, and they are worldwide. So that's real harmonization. So once you comply with those regulations, as a manufacturer, you don't have to adapt your product to the country. Now, just to the first item I would like to convey, the first message I would like to state, is that it's a key, this system is a key to export. If you are Chinese and you would like to export to Turkey, to Japan, to the European Union, to South Africa, to America, to India, or to, I don't know, Brazil or Australia, you just have to comply with those United Nations regulations, and the markets are open. Also, I would like to remind that the suppliers, the Chinese suppliers, feed up to 50% of the Western world manufacturers. So the network already exists. So that the first key message is that it's a plea for the Chinese manufacturers to accompany us at OICA in the discussions we have at the United Nations. Now, a second message is about the introduction of the ICV, what we call at the United Nations, we call them the automated driving systems, AD or ADS. At the United Nations, we have already one regulation that is in place, which is called the regulation number 157, which addresses the automated lane keeping system. That's the level 3 of automation, lane keeping assist plus the auto lane change below 130 kilometers an hour. So that's already existing. Yeah, that's okay, that's fine. That's already existing, so you can apply, or if you comply with that regulation, you can already sell L3 automation vehicles around the world. We are currently discussing about adapting that to the heavy commercial vehicles, because what we are discussing at the United Nations not only covers the cars, but also the trucks. We had until June this year, a group, by the way, 2 groups about the automated driving system regulations that were what we call the FRAV and the VMAT. That were 2 groups that were preparing the regulations for the ICV, for the automated driving system. And now, since May, so I would say May 2024, we have now these 2 groups finalized their work, and they transferred that to 2 other groups that are the ADS, Informal Working Group, and the workshop on ADS under the 58 agreement and the 98 agreement that are the main agreements at the United Nations for the development of the regulations, for the construction of the vehicle. They are developing some new regulation that hopefully will be worldwide harmonized for the manufacturers. We also adapt the regulations that are not related to the automated driving systems. For example, so this task force FADS on the dual mode vehicles, that means the vehicles that can be driven with a driver or without a driver. We adapted the regulations related to the braking system for the case when there is no driver to press the brake pedal, for example. So we hope that this work will be finished at the end of 2024. And we will enter a new phase with the task force FADS about the other categories of vehicles or the other regulations, with the hope that they will finish maybe at the beginning of 2026. Now, in Europe, so maybe you don't know that, but in Europe there is a policy decision to rely fully on the United Nations regulations. So in Europe, all the regulations governing the construction of the vehicles are totally inspired or developed from the UN regulation. So in Europe, they have developed their own directive. It's a regulation for the automated valet parking, AVP, for the small volumes. That's restricted to the small volumes, and they are currently working on removing the limitation to the small volumes for the automated valet parking. And as from this summer, they will start to discuss the other use cases, because the automated valet parking is only one use case for the automated driving system. So we start small, but progressively they will expand to other use cases like hub-to-hub or robotaxi. Now, the plan for them in Europe is to have a fully complete automated driving regulation with unlimited volumes and unlimited categories of vehicles, unlimited use cases as from 2026. So what we do at the United Nations, so we hope that at the beginning of 2027, the two groups I was talking about, the ADS and the workshop, the ADS informal working group and the ADS workshop, will have finalized the UN regulation and the GTR. So these are the two main regulations that we expect will govern the automated vehicles. And then on the top of that, you can see that we expect that regulation to replace the existing regulation 157, and in Europe, as I said, we can imagine that they will replace the own regulation by that UN regulation. So in that case, for the automated vehicles, it will be fully harmonized. Now, for the other regions, I took the example of the USA or China, that could be also Turkey or the UK. Perhaps in the USA they will develop FMVSS, and perhaps in China you will have, or you probably are constructing regulations for the automated vehicles already, and maybe a GTB. But the hope is that this GTR that is developed at the United Nations will be applied as well in China. In that case, we as manufacturers will have a set of worldwide harmonized regulations permitting to sell the automated vehicles worldwide with no change. So this right part in the red circle is not yet decided. That's a hope, but that's the purpose of all the exercise. Now, the conclusion. First, so these are the main items I would like the main messages I would like to convey to you. So the UNECE and the regulatory harmonization are a chance to export worldwide. If you want to export vehicles worldwide, the best is to comply with the United Nations regulations. We need the presence of the Chinese manufacturers at OICA. For the moment, in particular for the development of the ICV worldwide harmonized regulation, we have the presence of the Chinese government, so Qatar, but we are missing, unfortunately, the presence of the Chinese manufacturers, and that's a pity, because then the decision will be made without the Chinese manufacturer. That's a pity. You have all the place you need at OICA to help and to influence the decisions. So the presence of the Chinese manufacturers at OICA promotes the UN harmonization, because, of course, if we talk about worldwide harmonization, that cannot be done without China. And this will help streamline the Chinese production. Because, of course, as I said, if you comply with the UN harmonized regulations, you can sell anywhere in the world, at least in the countries signatories to the, or even beyond those signatories to the UN regulations. And then, so yes, the last message is that the introduction of the ICV, so the ADS, the automated vehicles, needs the Chinese manufacturers. So that's the three big messages I want to convey today to this audience. Thank you very much for for having listened to me, and so I'm very happy to be here. Thank you very much.
谢谢方坦先生的分享。那么大家知道啊，这个刚才通过这个介绍呢，就是奥伊卡，在国际法规协调方面发挥了重要作用。那么大家也知道呢，就是我们改革开放以来，中国由这
China's opening and reform till now, China has gone through a long journey to become a big automotive manufacturing country. And we have welcomed the world-leading OEMs to China. So the regulation harmonization is very important. In the joint venture period, we mainly follow the UN and the EU regulations. And when looking at the electrification and the intelligent vehicles, China will have a leading position in the innovation. And the laws and regulations harmonization is also more important. In the morning, in my presentation, I talked about internationalization, and in which the harmonization and mutual recognition of the regulation and the standards is increasingly important. So this is also an urgent task for us, especially we are having larger and larger automobile export. Last year, the number is over 4.9 million. And in this year's first half, we have already reached over 2.3 billion, if I remember right. In the future, we also will have investment in all the different parts of the world. And for China's NEV and ICV, the achievements of our innovation will also need the support from the regulation harmonization. And we suggest that China automotive manufacturers play an increasingly important role in this field. And CAM is the alternative chairman for this period. And in the regulation harmonization, we carry out this work together with enterprises. This is a very professional topic. And we also have the engineers from Huawei to take part in this discussion and exchanges. I encourage all the other technical leaders to participate in this work. Thank you very much, Oliver. And now we would like to have our next speaker, Mr. Zhu Yanfeng. Mr. Zhu Yanfeng from Dongfeng. And we will invite him to talk about the hybrid technology and the future trend. So the hybrid is started from Toyota's HEV. It was introduced to China as well. It is really good at the fuel conservation. But the motor is with a limitation in the power. So later, the displacement of the motor is increased, and that was the first generation of a hybrid. And with the electrification, and we have the full hybrid, and we have the mild hybrid, etc. The hybrid will look more and more at how strong the motor is, the range, and the energy conservation performance. Okay, now we would like to give the floor to Mr. Zhu Yanfeng to talk about the development of the hybrid technologies in Dongfeng Motor. Let's welcome. And dear colleagues and dear technical leaders, good afternoon. The topic is about the hybrid technology innovation. And in our work, we have a long study in the hybrid. We also have the BEV and the ICV, but Chairman Fu also asked us to introduce more about the hybrid technologies in Dongfeng. And when I think over this topic, I also have collected some information. And I noticed that Professor Xu Ming from Jiao Tong University published a paper in 2024. The third edition of that journal, he has published a paper. And this has a lot of information shared in my presentation, but more detailed. And I believe this is a good reference. And I suggest that you can read the paper of Professor Xu Ming from Jiao Tong University. And I will look at three major parts: the history and the representative technologies and the future outlook of the hybrid. For the first two parts, I will give a brief introduction. The history, if we look at the development, the drive of the hybrid is from the cost effectiveness and the emission regulation and also the energy conservation. And these are the major drive for the hybrid development. So we know that the dual credit policy and the hybrid energy conservation. So here, the graph at the bottom is provided by CAAM. The green part is BEV, and the blue part is hybrid. The gray part is ICE. And I feel that in the future, the ICE will be smaller and smaller, approaching zero. And this part will be replaced by the hybrid. The hybrid in different models and different technology routes. And the ICE in 2030, I don't see any further development of it, because in the electrification, if we look at the history of the industry development, electrification will drive the cost down of the hybrid, and in turn, it will drive the development of the hybrid. So if we look at 2025, ICE will have some space, but in the future, the replacement by the hybrid will be accelerated. So in the future, vehicle will have a diversified method of a hybrid and the BEV. So this is technology principles. I know that you're all the CTOs. So we see that for the ICE, we try to keep the optimal energy conservation and efficient period. So that is in the optimal zone. And on the right, that is different hybrid structures like the power split and P1 and P0 and P2, etc. And for the parallel and also the power split, it is a patented technology of Toyota. So when we look at the hybrid, it started very early. In the early years, Porsche started the first generation and the first model of the hybrid. At that time, people have been thinking about to make some improvement on the ICE. In 1900, the first model was invented, but at the time, the technology was thought to be too complicated because the controlling is not updated enough. And in 1920s, there is another generation of the model, but the cost of the batteries is very high. It also got another progress in 1970s with the oil crisis. I remember that Toyota, at that time, the president, at that time, he mentioned that when he first started his work in the procurement department, the boss has given him a task, that is to develop a energy conserving technology. So this is started from Toyota. And 20 years ago, when we were cooperating with one another, I got an opportunity to know about this story. And from 2003 and 2005, in that period, I was working in FAW, and we introduced the hybrid technology in our cooperation with Toyota. That was the second generation of the hybrid. We planned to promote this technology, but the cost, price, and the technical bottleneck prevented the development. And this is also from Professor Xu Ming's paper. In China, we started BEV first. In the auto industry, we had the difficulty in the battery and the cost control of the battery, and then we use a small portion of the battery, and when the battery part is getting higher and higher until it reaches 100%. And this is a BEV. But in China, the mild hybrid was not getting the subsidy from the government. So we directly started from the plug-in. And this is a change happened in China. And when we look at the BEV, this was a starting point in China, and then we expand to the plug-in. And also, we look at the hybrid with the prerequisition of getting the government financial support. And then we have the parallel, the linear, and all the different solutions. So you can see these are the representative technologies. If we check the third column, the layout of the motor, most of the technology are P1 plus P3.
Let's look at the gears of the engine. 1 gear, 2 gears produces 4 gears, P1 plus P3. Why the power split? The technology, how it works in China. For example, the pump, the heat management, technological technology, product A, product B, and the people know which product it belongs to. And it is available in China. I should say it is pretty enriched. And if we want to choose, and because the brand is confirmed, and once customers has been confirmed, I should say that the requirements have been met. And I want to talk about the representative technology of hybrid. And one of the features is that in passenger vehicles, and it is a 1.5, and also it has hybrid, and of course there might be some changes in the parameters, and also in the extended range it also uses it. The hydrogen is another system, and in the hybrid it forms a 2+2 layout, and also 2+N layout for the extended range based on the power and its needs for the extended range. At the same time, and probably people know it, and I will not go into details. And generally speaking, that is a 2+2 and a 2+N for the extended range. I want to talk about PHREV. It is not a new concept. P is the plug-in, which meets our minimum power subsidiary, and H means hybrid, and R, which means the extended range. Electric vehicles expensive because of complexity. We do the followings on R. R means extended range, and we have been working on it. And for example, in the middle, And originally, we have made it 2 shafts. Seemingly, the volume is larger, but with a simpler structure. And we have a multiple gear. Not only we have power split and plus several gears. And the other one is that in the engine, we have high efficiency, the electric motors, and also the oil cooling. And in the fuel engine, we can increase its heat efficiency, and 45.18%. And the other one, we have to identify the people, identify the infrastructure, and some of the cloud algorithm could be included, and scenario-based algorithm plus AI. Talking about the future of hybrid power, there are several things in our mind. First of all, DHT and also DHE has been quite widespread. Most importantly, to utilize the existing technology for the better design. And for example, from 400 to 800, and that is for the detailed analysis. And if we look at the hybrid and the better efficiency, and in this part, at present, and the people are now working on it. And in terms of innovation, it's not about the structural or the scientific solution. Based on the current solution, we need to refine and deepen our work. And in terms of AI technology and scenario-based and smart driving technology, and we have a lot of engineering work to be done. And secondly, based on the cloud or the navigation system, and actually inspired by Toyota engineers many years ago, I visited one Japanese company who is working on the navigation, and you have navigation on both piles, but the other one is to identify the slope up and slope down, and to adjust the clutches. At the same time, in the hybrid power and these the Baidu technology, transportation signals, and the cloud technology, and we can intelligently split the controlling system. And in this aspect, and we need to identify 1 or 2% of the fuel saving is possible, and we still have a great potential there. Third one is the hybrid. As the engineer, and I talked to our team. So our consideration is that a hybrid and how to mix the electricity into the mechanics, and how to split the extended range with the progress of the fuel engine, because it has been good enough. However, with the e-fuels, it's also a green fuel. On the other hand, and with the electric as the priority in certain scenario, if the cost performance is allowed, and we need to have, for example, we have the positive hybrid. But now we take electricity as the priority under certain scenario in the expressway, and the less torque and on expressway. Think about 10 millions of motor cars, and the cost. Of course, the engines were not as good as what we have now, but you know, the cost is low enough. There might be a very large enough torque available, which will bring in a great improvement on the electric vehicles. But it's about which technology you want to choose. One of the innovative points, can we think differently, and we can take the power as the under certain circumstance, and we could make it possible, and probably, and we may have a better technological innovation. And the other thing I would say, next step the hybrid power, there is a very actual application that is on the commercial vehicle. Once widely used, the result will be very nice. And these pedestrian vehicles, commercial vehicles, if the commercial vehicles can use it, and also after utilization of it, the result will be very nice. And we have concern on the cost. But with a higher percentage of electric vehicle, and the electric vehicle, and the cost is transferred to the commercial vehicle, it might be low enough. And so the commercial vehicle hybrid technology is there, and especially to the diesel hybrid technology. And that will be, personally speaking, will be a very promising aspect. So that is my presentation. And in terms of the hybrid technology, 4 things is that we have a serial and in parallel and the power split, and the other one is the ICV and the mechanical technology and the reverse hybrid and utilization with the commercial vehicle to further expand application, and which will bring a better economic social benefits such as the energy saving, emission, and also and if it is E6 is going up, and we will have a better promising future. Thank you. With that, I finish my talk. Thank you, Mr. Zhu, for your sharing. Probably you already feel that Mr. Zhu has a great technical background, even though he is the former board chairman of Dongfeng Group. But he didn't mention the name of Dongfeng or recommend your own products. So such a good technology and how it works. So I want to make some promotion here. And this technology, for example, it's Lantu series and also Hongshi series. And I just take the second one as an example, and which is a 3-ton heavy, 3-ton, and the military application, 3.3 tons military electric vehicle and hybrid vehicle. And the people may have a chance to test it. And the 3 tons of the vehicles in driving, and if we could accelerate, decelerate, and turning rounds, you can feel the weight on yourself is quite light. But 3.3 tons, we did not. It's like a light-duty trucks. But if you drive it, and seemingly the weight is combined with your own. And one of the technology, and I feel quite thrilled, that is 40 degrees slope, and you can use the automatic ways for downgrade or for the sloping down. That is the power system with the combination of intelligence. 40 degrees. So it's like this way. If you have a skiing experience, and with the press, you have a button you press and it can go down smoothly. So that is the technological evolution brings the upgraded consumption experience. Just now we talked about hybrid technology, including the plug-in. Such a technology is very enriched. And I should say, and in this aspect, and the development is quite leading. And the multi-scenario application, as long as the electric vehicle find it difficult, it might be the potential for the hybrid. And Mr. Zhu and go to understand driving Dongfeng vehicle and the degrees and in the sense, and they still drive the car, and it's very outstanding, very good technological progress which brings a very new experience. And this morning, and the people already feel it. And when this industry still have its anxiety, and as entrepreneurs by technological innovation, we need to meet more the needs of more customers. Thank you, Mr. Zhu. And it is the first time that you join us in this open forum for making this presentation. Thank you. And now I'd like to invite Deputy Head of SAIC Motor R&D Innovation Headquarters, Mr. Qiu Jie, who is going to talk about the solid-state power battery technology, correct? Yes. Not long ago, on May the 24th, President Xi visited SAIC, and this scientific 10th anniversary of this scientific pathway for the NEV, and SAIC shows the advancement in technology, and the solid-state power battery technology is a core technology to be mastered by SAIC within the next few years. I really want to thank the conference organizer, and actually originally it should be my boss to make the presentation, but here it's me to make this presentation.
So I would like to, on behalf of Mr. Zhu, to share with you the solid-state power batteries development in SAIC. So I will talk about the technology and also the industrialization as well as the applications. For the solid-state power battery, it is based on the traditional lithium-ion batteries. It has the higher energy density and it is safer. It also has a higher level of cost effectiveness. So, as mentioned by Mr. Zhu, the hybrid has a good cost effectiveness, and the battery is also pursuing the higher cost effectiveness. So solid state is regarded as the major battery for the next generation. And in the solid state battery development, a most important part is the industrialization and whether or not it can be applied in most of the models. And when we look at the principles of the solid-state battery, it is quite similar to that of the electrolyte ones. And I know that there are a lot of higher, and the internal resistance is lower. The major benefit from it is that the whole vehicle, the discharge, is getting more efficient. And with this, we see that the battery is EC for 1C and to the 4C and to the 6C. So we see that the performance is getting better. With the application of solid state, it will be more promising in using in the hybrid vehicles. And another is for the anode and the cathode materials and the changes of the materials. High voltage will have a positive influence on the cost effectiveness of the battery. And in SAIC, development of the solid-state battery, we started from 2015. We, in that year, started our investment in the solid state. We also work with the battery manufacturers and have a deep down discussion with our suppliers. From 2016 to 2019, the biggest challenge in that period is to have the discussion with the industry players, the experts, especially to have the profound discussion on the technology. In 2021, we have built a solid-state battery R&D laboratory in Qingdao with the Qingdao Energy. And we developed a demo and finish the test for a vehicle with a range of 1,000 kilometers. In 2022, we built a joint laboratory and we focused on the products. And in 2023, we built a joint venture. And this also quickly set the goal for this year. That is the mass production for the solid-state batteries. In the development of the solid-state, we have gone through 3 phases. The first is the semi-solid, and the second is quasi-solid, and the third is the full solid-state. So the product with a mass production of 2024, the electrolyte is 10%. The second phase is with the electrolyte less than 5%, and the third phase is a full solid state, that is 100% solid with no electrolyte. And R&D is important, and we believe that more important thing is the industrialization. This year is also a very difficult year. We overcome a lot of challenges, because in this year we are going through a very important phase, that is the mass production and the commercialization. So in the phase 1, there are 3 major challenges, and also the user experiences. So first is the energy density. We hope to have it surpass 300 watt-hours per kilogram. This is a quite big challenge for the liquid electrolyte battery. But only when this level of energy density is reached, we can get a range of 1,000 kilometers range. I specialize in the hybrid structure and control. In my view, the speed and the range are the most important parameters. So the discharge efficiency is about the response of the system. And the second is for the charging. The semi-solid state voltage is need to be getting higher and higher. So for the charge and discharge efficiency, we need to realize the speed of 12 minutes, 400 kilowatts charging power. This is to help to remove the mileage anxiety. And the third is safety. 10% of the electrolyte. This has made this battery safer as a whole. The second phase is a quasi-solid state, and we have 2 major tasks. One is that after the study and verification of the first phase, we need to expand the performance and optimize the battery in terms of the material and the formulation of the material to satisfy the different demand of the range. 2 parameters are more challenging. One is the conductivity of the solid-state electrolyte materials. And second is the liquid content. As we mentioned, the phase 1 electrolyte is 10%, and the next year's phase is with a goal of 5%. Mr. Fu also mentioned that in 10 years, we may have more higher technology requirements. So this is an evidence of that. So we know that a critical part is material, like the high voltage cathode material. And second is the process, like the dry process. And the third is also the most critical one, that is the electrolyte interface, to have a better design of the layers to effectively improve the ion exchange rate. A very important task is adaptivity. That is, when we have a hybrid technology, we need to adapt to more complicated and harsh scenarios. And when we need to apply to the BEV and the PHEV, these are the challenges that we have to deal with. And the third is, for 2026, we will go into the phase 3. So 2026 marks the challenges on two aspects. The first is energy density. We need to further increase the energy density to 400 watt-hours per kilogram. This requirement is very high, and the system energy density will need to be 288 watt-hours per kilogram. Light weighting and the range keeping will need to be very important. So in 2026, we will go into the 100% solid state. And in this process, we have to make sure that the different scenarios can be satisfied. And among all the scenarios, two requirements are very critical. One is the 25 Celsius ambient temperature energy regeneration, and second is the minus 20 Celsius. In that low temperature, how can we do the energy regeneration? In the laws and regulations, it mentioned in Euro 7 that the temperature range requirement are getting higher, especially for the low temperature and the high temperature performance. The requirement is getting higher. So for the hybrid, the high temperature balance of the performance is a major task. We have a goal set for our system. One is that in the solid state application, the energy density and the battery size will be reduced by 50%. The whole curb mass will reduce, and this will help to improve the energy efficiency. So we know that in Europe, the carbon credit requirement is very high. And in SAIC, in our development in the EU, the biggest challenge we are having is the 100 gram of CO2. Like a Prius, the THS, this is 96 grams. And if we cannot reach the goal, we will see a penalty because of the credit. And that is one challenge. Another is for the mass and the density ratio. If the curb weight is higher, the energy consumption is higher. So in the end of 2026, when we see the Euro 7, which is implemented in the third quarter of that 2026, it has higher requirement on the carbon emission reduction.
It might be a 95%, therefore solid-state battery to the electric vehicle. I should say the solid-state battery is a very important product to SAIC, and also for our overseas business, this is even more important because the PHEV, in terms of the power density, and after Euro 7, the carbon dioxide test direction, it might be 50% lower, and therefore the batteries plays a significant role, especially in the PF, the solid-state battery. And I want to share this with you. We always talked about the solid-state battery is always used for electric vehicle, but now we have a higher focused, which means that in hybrid, because we already get some very good benefits, and that is the 47 tax. And this HEV overseas business plays us significantly. And in this process, we also encounter some issues, and also some new promotion is made. First of all, and we try to have integrated parts to lower the number of parts. Most importantly, that is to lower the weight. Lower the weight is very important. It is ongoing topics. The second one, and in lower this weight, we have tried to protect the security, ensure the safety, and also the battery chip as well as its package. The other one is the battery life cycle is also very important point. Why it is so important? Because and Mr. Zhu already mentioned the Euro 7 or the emission, the hybrid emission. Euro 7, there is a very important indicators, probably people know about it, that is SOC, the life cycle 5 years, and also SOC 80% or 75% requirements, and therefore the long life cycle of the battery. In terms of the package, we need to ensure the uniformity of the temperature as well as integrated design. So we try our best to optimize the design, including the safety and also the long life cycle. And in the condensation, how to ensure the single battery uniformity, and we can ensure Euro 7 and the Euro 6 SOC requirement. And finally, I want to sum up. And today I'm here. I want to learn from you, and also I try to present and report to you our status quo. First of all, in the BEV, I should say that solid-state battery will be grounded this year. The other one is the hybrid, especially the multiple times, 30, 40, or even 50, 60 discharge. And there might be some in-depth research based on these two aspects. Generally speaking, the solid-state battery, I should say, and we used to focus on the BEV, but now we try to cover the full range, including the hybrid. And in package, we want to provide more lightweight solutions. Thank you. And thank you, Mr. Zhu, for your wonderful sharing. You talked about the core technology to these companies. A solid-state battery is a disruptive technology. Of course, more innovative, a lot of innovative practice should be further optimized. Just now, and the staff said, by now we are already delayed much, and so I try to avoid these comments. I'd like to leave more time to you, and if more time allowed, and probably we can have more interaction. I'd like to invite Mr. Wu from Cherry Automobile. Thank you very much. And actually, it should be Mr. Ying should be here. The presentation is made from his perspective, but his time is out of his control. So I'm here to make this presentation. I want to share with you, and in the recently, and the four trends, and in terms of technology, some of the considerations, and it is entitled as the technology for the future. You know that we are ushering in the new age for auto industry. We expect some mega changes and how the technologies will be involved. So we will look to 2025. Within this system, there are 5, such as the safety, energy consumption, space, intelligent cockpit, intelligent driving. These are 5 important aspects. I want to talk about them one after another. Safety is the top priority, and we say that it is our religion. It is our true faith in safety. We must have full trust in the auto safety, because it is a vehicle in motion with a certain level of velocity, with a certain level of weight. It is moving in the open space. And from this perspective, it is a conventional safety and also active safety and functional security. And we talked about the safety, and sometimes it is not only about the safety, it is about a very specific safety and the security. Cyber security, information security, data security, and all of them, and which fall into a mega field or scope of it. And so, and we believe that safety or security is the top priority, is the top luxury. Let's talk about the passive safety, because worldwide speaking, and that is our target market. We must meet the global technical standards, and for example, the world-class 5-star battery, safety of the battery, and we have 1 + 8 + 1. One refers to the battery chip. The other one is the battery structure and the package design. We have 8 technology for the battery design. The last one is the real-time monitoring of the battery, and it has been a Gen 2. And we have a lot of battery data trained by the AI models. Is not 100% accurate, but it plays a significant role. So that is about the safety. And the other thing is the power consumption. Power consumption is the responsibility. And first of all, let's look at its design and the production and such a cycle and the whole value chain to generate one vehicle and how much power should be generated. The second dimension is the utilization cycle, and one new vehicle from being available to being scrapped, and in this process how much energy is consumed. And the third one, and the connection with the energy. And here it's about the choice of the power, hybrid, HEV, PHEV, BEV, or others, and the selection of the power. And I should say behind the power selection is the regulations, the fuel regulation. And if there is no such requirement on the emission, people will continue to use IEC. But with the regulation, people have to make a new choice. And of course, electrification, because with the development of a battery technology, and maybe it's about the competition between the electricity and the fuel, but now they are complementary and cooperative with each other. Talking about auto energy consumed, and by now the selection of the vehicle, it is quite evident. It's about the cost and why these electric vehicles, and it is very evident because the electricity cost is low. Because it is all included from IEC, battery, and different aspects. and it has been very well developed. The other one is the space, and we still believe that cars are a home on mobility and with a higher level of intelligence, and it has more properties. So the space is your home, and we will not only consider it is large enough. A large space is one of them. We have absolute large space, and especially in a comparatively speaking large space. On one hand, we want to rationalize the structure so that it has no impact on the storage, the luggage, and interior space. And it is all about the space. The second one, and the other one is that when people sitting in the vehicles, people feel very comfortable with strong sense of home. And to meet the needs of the users, the requirements of the users. For example, the car in China has one feature, and maybe it's not so common, and you know that you can slip in the and it will slip because the Chinese users sometimes slip in the cars, and therefore there might be some issues, and it happens to fit into the requirements, and that is very special. And in terms of internal design, and it comes up with relevant requirements, and you know sometimes the foreign guest would feel very confused the Chinese requirements for space, because sometimes it is needed for sleeping. And also intelligent cockpit is a virtual, it's not only a physical vehicle, it's also a virtual ecosystem. It's kind of a virtual friends, a good friends. You know, sometimes your best girlfriend is never reliable. She will give tips to others, but intelligent cockpit is your most reliable friends. And all these users and the data, and also the data accumulates into the end of the OEM with the arrival of AI. You know that the data is the king. Those who have the data, who has the money, and so intelligent cockpit is so important. But it is still very difficult. It is a multidisciplinary integration. For example, software, internet, and to the conventional OEMs, this is not something very easy. Semiconductor, the select of these semiconductors, and you know that we have to follow the semiconductor companies. It's like military or the army races. The other one is the telecommunication technology, which is the weakness of the auto companies. In the future, there are all kinds of V2V or V2X. V2V is most difficult. By now, there is no feasible technical solution. If it's and we may able to lower the accidents by 95%.
So when we look at the technology integrated in the intelligent cockpit, so we see that it has collected lots and lots of data, and it can satisfy the need of the large model. So the intelligent cockpit is very important. And also for the intelligent driving, this is very important. It also represents the future. And every company, if you don't have the intelligent driving, you cannot say that you are an automotive company in a real sense. And now we are transforming from ADAS to the intelligent driving. So we see that a lot of experts are presenting today, and you will all have a rich experience in this period, in this part. So we are looking at the intelligent and the NEV products. So we have the series, 4 major series in Cherry, And I also hope that you can pay more attention to our products. We hope to build the cutting-edge technologies and to look at the solid and trustworthy products in the innovation. We will look at the vehicle's reliability and also the safety of the vehicles. This continue to be the priority in our future product development. Thank you. Thank you very much, Mr. Wu. So this is a quite important presentation. Also, it represents the major principles for the innovation, including the energy consumption and the space and also the cockpit. Chery is a company focusing on the constant innovation, and the product sales is getting higher and higher. In the first half of this year, the sales is over 1.1 million units, and we believe that you will have a very great future. And now we welcome our next speaker, Mr. Jin Yuzhi from Huawei. Ladies and gentlemen, dear friends, good afternoon. I'm very glad to participate in this conference invited by Chairman Fu. And we know that the first half of the competition is NEV, electrification, and the second half of the competition is the intelligent development. So we try to use our technology to help with the foundation setting for China's intelligent automotive industry and to help the industry's future development. So we know that in today's vehicle, especially for the intelligent development of the vehicles, looking at today's auto industry, it's quite similar to the smartphones in the period around 2007. The featured phones has been gradually replaced by the smartphones. In the period of featured phones, we compete more on the hardware. If you remember, every company can do the featured phones and compete for the price and the outlook of it. So that was a period of featured phones. And in 2007, iPhone launched the first generation of smartphones, and this ushered in a new period. In the following 10 years, if we look at the smartphones, it is increasingly changing our life, and every year's shipment is over 1 billion units. So when we look at the development, so we see that it is with a focus shift from hardware to software. And in the 10 years development, we also can see that there is a consolidation of the manufacturers. In the smartphone period, ICE will be replaced by the hybrid. So the NEV and the hybrid will be the future. In the intelligent, no matter ICE or the BEV, they will both employ more and more intelligent technologies. And intelligent vehicles will become the major competition focus. And when users are making the purchase decision, they will first look at intelligent functions. So what is happening in the vehicle industry? And we also believe that the consolidation may also happen in the auto industry, and most of the business will be concentrated to the leading players in the industry, and the weaker ones will probably be phased out. And the window of the intelligent vehicle is opening. This is an opportunity as well as the challenges. So how to use the hardcore technology to help to improve the experiences. This is also the task of Huawei. Looking at intelligent technology, we will need to look at the software-defined vehicles. The core of this is the EE structure changes and modification. So for the EE architecture, so previously it's a fragmented ECU, like the different components, it has its own ECU. In the future, if we go toward the software-defined vehicles, the ECU, MCU, and the communication components will be integrated into one unit, and several domains will be the major body of the architecture. And when this is redefined, we can say that our vehicles is ready for the software-designed vehicles, and it will have the service-oriented architecture. Application will be used more in the architecture. So if we want our vehicle to be a space, like for a nap at noon, it will do the automatic adjustment of the lighting, of the music, or the others, and even the temperature. So the core of it is a module which can integrate all the control functions, ECU, MCU, exchanges, put into one box. Huawei specializes in the telecommunication. So the architecture we provide, education solutions, has the best performance, reliability, and the lowest latency in the industry. So we have the unique advantage in this part. And for the telecommunication architecture, we can guarantee for the safety-related telecommunications, it is absolutely safe. And based on this module, we provide 800 standard API, and the automakers can directly use the API and to do the efficient and fast development. So for this architecture, it is also in our cooperation with lots and lots of automakers. And also in the intelligent cockpit, another very important part is intelligent cockpit, like the Harmony-based cockpit and the OS. It is leading the direction of the intelligent cockpit, and the smartphone-based ecosystem is built. And we will also have the large model to be introduced, like Pangu, and also the hardware of Shengteng. And we also will use the perception of Harmony, and we also have the AI assistant Xiaoyi for the voice commanding, and all this will be a part of this architecture. And in this Harmony space, it is based on the Harmony ecosystem, and it is seamlessly connected with the 1+8+N architecture. So if you use this system of Huawei, you can use it on your smartphones and on your vehicles, and you can see the seamless connection. What you see on your smartphones can also be seen on the screen of your vehicle. The ecosystem can be shared by two platforms. This is also an advantage of Harmony space. And with the vehicle large model, in the intelligent cockpit, voice commanding, and also the other parts and experiences, we will transform from the people controlling vehicle to the period of vehicle know its user. And for the intelligent driving, so we see that from last year, we see the beginning of the intelligent driving. And the scaled commercialization is happening since this year. And when we start to use the autonomous driving, we see that the technology is really attractive. So from the ADS 1.0, we started the urban area NCA. So at that time, the NCA is based on the high precision HD map. But it has a lot of limitations because only several cities in China has this kind of HD map. So we start to work on another breakthrough, that is the map-free autonomous driving. And for the ADS 2.0, it is based on these solutions. So starting from the end of last year, when it is introduced to our users, so we see that our users can drive with our ADS 2.0 in all the different regions in China, no matter in what city. And the different scenarios can be introduced to the system. So this is quite new and fresh to our users. And our colleagues are also trying to launch this year, and I hope they can get success. And the next stage for us is ADS 3.0. This is another leapfrog. So we will see the parking lot to parking lot, end to end, all scenario integrated. Previously, we have the navigation from one park to another, but now we will connect all the different campus, and this will help us to realize that from your office parking lot to your home parking lot, we can realize the route design and navigation. So this is our ADS 3.0. To support this, basically, we start to use the end-to-end architecture.
And it is easy to sense, and it is end-to-end network. So from sensing to the decision, it is end-to-end. And that is the information delivery or transmission. And the decision and information is based on the NO network. And what is the experience? And we can expect more accurate results and highly efficiency. And that is the overall experience, and very good. And it is more human-like. And in the past, we focus on the safety and the security. But here, in the experience, we can have a big progress made. And in the consumer side, our users, and in Q4 this year, step by step, you can experience these parts. And also, because intelligent solution, and how to better serve the auto companies to build a better products for the users. Next month, we are going to release the S9, and in collaboration with the BAIC, and that is a flagship vehicle. For the first time, it will have Huawei HS 3.0. And also in M9 and in Cedis, this is the whole scenario, flagship SUV, and M9 also is kind of a benchmark. It creates the history, and 500,000 RMB. It is the top in sales because all the intelligent technologies enabling this vehicle. At the same time, on Aveta, and in the smart vehicle, it will adopt AVS 3.0 for the first batch of utilization. And therefore, why it demonstrates so many features? Because it is the luxuries, and it is more like a technology and a modality. And if we look at our partners, we are creating history to our partners and to create a truly luxurious and premium car brand. And I should say that these are very typical representative. And surely, in our discussion just now, Mr. Zhu and also Chairman mentioned, and also Mengshi and Dongfeng and also Lantu, a premium brand, a premium products from Dongfeng. And step by step, they will use our ADS and also also we are able to realize the safe and luxurious, because we have very good results, and it is very popular among the users, and it is such a good one, and 250,000 or 300,000. And can you offer used for more users? And that's why we come up with, and for the benefits of the intelligent ADS-E. And for the first time, the vehicle below 200,000, we are going to have ADS-E on the deep blue S07. It will be available. And we are the ADS available on the vehicles with 200,000 selling price, and NCV and other assistance. And we can help our companies, help the OEMs, and to make it available on the vehicles with the selling price above 150,000, so that the drivers can enjoy the benefits of intelligent driving. And at the beginning, Oliver mentioned UNR 157, and which is defining L3 less than 130 km/h in changing the lane, and China is also picking up the speed, and L3 will have a higher utilization of the time, and it will be tested in China. And so we already moved into the pilot, and we try to accelerate the progress in a technological perspective. Next year, the second half of next year in L3, and we already have these commercial capabilities. We are ready. So to us, and we are going to provide a intelligent vehicles added components. And we rely on our experience in ST technology, our accumulation, and we apply it to the vehicles, from the intelligent vehicle, and from the chips to the OS, and to the upper side software. It is a whole solution. It is a closed loop software, and to assist the intelligent transition. And such a positioning together with our partners, and we have various kind of cooperation and offer tier 2 and to tier 3 in them, and together with our strategic partners in terms of whole vehicle definition, design, and to the and the whole stack collaboration, and such as the Aveta. And it is kind of a holistic strategic partner. And together with the partners, we will co-build an ecosystem, and we want to to make this industry better and larger, from the industrial application to intelligent application. You know that the mobile phone market has been growing by multiple folds, and we also hope in this process and we can enlarge this industrial space, and by working together, and we are able to improve the high quality development. Thank you. And thank you, Mr. Jin, for your wonderful sharing. And I should say that Huawei in the auto sector is the leader in innovation, especially in intelligence. And Huawei does not make a car because they work with the OEMs, and to indicate is a technological application. And also in the PPT, and we do see that it's like a screw, it's kind of electric partner. And I believe that Huawei is more than a small component or screw in the vehicle. You are the leader in technological innovation. We hope that we can know more about your technology. Next, I'd like to invite CATL, Mr. Wu Kai, who is going to catch the plane. And after you, we are going to have some interaction. We try to control the time. And just now, we have a reminder. And our volunteers already remind me. Distinguished leaders, dear experts, good afternoon. My name is Wu Kai. I'm from CATL. It's my great honor to share my presentation with you, because when CATL is mentioned, and we need to mention the solid-state battery. Just now, Mr. Qiu has been very clear. I just want to share with you another perspective, and that is the battery bank innovation to promote the V2 network interaction with the NEV has more car park, a large-scale charging has a big impact on the loaded network, and as the energy storage as the buffer plays a significant role. So V2 network brings flexible peak shaving capability, offering more benefits to the users. That is a multiple win, and it helps the countries to make energy transition. It is highly significant. And by the end of 2023, NDRC, MIIT, and the other 4 ministries printed and issued documents on the NEV's interaction with the grid. It clearly points out that V2 network whole development to promote V2G modality. Shenzhen, Anhui, Fujian actively make responses, and there is a lot of policies available, and it will have a lot of scenarios and great economical benefits. At the same time, and this V2G is still in its initial promotion, and by now a lot of issues, and there is a poor progress, such as V2G, and it remains unchanged. The battery SOC is not given higher requirement. Charging, discharging, the peak mechanism for the electricity should be built. We believe that battery bank as a new business model will become a way to break down these issues mentioned. The battery bank can be supported by the OEMs, the battery makers, and operators, the grid companies, and to be specific, by the vehicle battery separation, whole life cycle application management for battery, so that a vehicle pillar, and that is the energy two-way interaction. It brings the several aspects benefits. First of all, stability. And by a massive battery and data management, it offers leading batteries, and also dedicated network strategy, and accurately responds to the requirements, and to realize that we are able to shape the peak, stabilize the grid. And the other thing I want to mention, and that is the battery SOC, more SOC. After separation, we are able to provide a long cycle and long durability batteries, and also closed loop management, and with the live monitoring, and to work the optimized charging and discharging strategy to extend the power life to ensure the life security. Thirdly, to have a more economical performance. You don't need to buy the battery package. You need to pay the rental by month, which will greatly lower the cost and help the promotion of NEV. And by the battery bank, they engage in this action, and also to further increase its economical performance. And by now, the battery model barriers is the policy, and non-swappable cars cannot realize the replacements or separation. And therefore, we call upon the relevant department will further improve the top design, allowing the V2G vehicles to separate the battery from the vehicles and to manage on the two invoices, and also at the promotion of V2G from now to 2027. And we can take reference to battery swap to give the similar treatment to V2G. On one hand, and in the public administration and the vehicles with V2G, and that will be a single management. On the other thing is that we have to examine some of the tax, and so that we can accelerate this process and a better promotion. And these are some of my ideas. I'm open to suggestions. Thank you. Thank you, Mr. Wu, for your wonderful speech. So according to the agenda, we are going to have an interaction. So based on the solid state battery, and also ICV technology and others, and hybrid, and we can have some interaction. And we can have questions and answers from inner parts of the meeting room, or and also the outer ring of the cycle. And why not we start with Mr. 14?
就是还有这个什么呀？有这
Do you have slides to go with you?
Can I have control of that?
这个遥控器。遥控器。
So here, please use a remote control.
So I'm Ida from the Toyota, and thank you for giving me this chance to talk about small things. This time I'd like to talk about Toyota's powertrain development strategy to achieve carbon neutrality. It's very important to consider the future of energy and prepare diverse options to ensure reducing CO2 emissions. As one of the diverse options, every OEMs are pursuing its own battery EV initiatives. But as Mr. Zhu mentioned, HEV technologies, including ICE, is also represent a necessary multi-pathway technology. To promote the popularization of the electrified vehicles, we will pursue the new values required of powertrains and evolve them into one that are suited for the future energy environment. Today, I talk about the hybrid-related technologies, including ICE. Can you, the next slide? Everybody can do that. Oh, sorry. Thank you very much. Thank you. This shows the engine-related things, and Toyota is now Last month, Toyota announced that we are developing brand new engines, which is suitable for electrified powertrains. The concept is compact and also the high efficiency. Furthermore, it will be compatible with carbon neutral fuels. In the idea that the engine and motor work together, considering the engine and motor characteristic, engine thermal efficiency can be higher and the engine design can be also very, very compact. We are developing optimal engines for electric-rich HEVs and also PHEVs. Regarding 1.4-liter L4 engines, we are developing natural aspiration and also turbocharged engines. Compared with Toyota's current L3 1.5-liter engines, L4 engine height can be 10% lower and volume can be also 10% less. Because of the compact engine, it helps vehicles CD smaller and it expects 12% less fuel consumption in the sedan class vehicles, including improvement of combustion technologies. Of course, it can maintain the vehicle power performance too. 1.5-liter turbocharged engine can cover heavier vehicles which requires 2.5-liter natural aspiration engines. And 2.0-liter turbocharged engine, comparing current 2.4-liter turbocharged engines. Engine height and volume can be also 10% less, and output power is higher than current 2.4-liter. This newly designed 2.2-liter turbocharged engine can cover heavier SUVs and also sports cars with offering lower fuel consumption. This slide is about the HEVs, and Toyota has been developing THS, we call Toyota Hybrid System, and we will be improving the performance. And as a new HEV system, we launched dual boost hybrid system, which is one motor hybrid system. Newly designed drive motor with 6 AT, which has dual clutch system. This can realize higher motor torque assist and powerful acceleration. Controlling the dual clutch system precisely, the engine can be started and stopped smoothly and quietly in any driving conditions. Evolution of HEV system, we believe low fuel consumption and good performance can meet customers' expectation and help the CO2 lower. In the future, we believe electricity and hydrogen will be the mainstream of the energy source of transportation, and battery EV and FCV will become mainstream too. However, considering the current energy situation and customer needs, the engine-based solutions such as PHEV and HEVs are still very important. Thank you very much. 谢谢。
好啊，谢谢汤金先。
Thank you very much, Mr. Yuda. Toyota is the leading pioneer in the HEV and also looking at the upgrading of the technology. So I would like to thank Mr. Yuda. And do we have other experts? Do you want to raise questions to Mr. Zhu or the other speakers? So here we have a question. Please get the microphone first. Please use a microphone first.
你自我介啊？安博车企啊，你问的问题呢？要给他后边来了。哦。
Yes, we have a question. The question is about the whole vehicle cost control. Because Mr. Zhu and the other leaders, you have rich experience. So, like the Model T, when the cost is down, the sales is getting higher. So my question is, for Dongfeng and also for Chang'an and the other automakers, do you have the technologies promising for the future cost down, like to cut it by half? Do we have these kind of technologies? Well, yeah, this will maybe take us 20 years. Maybe new materials. So, can anyone give a feedback? So I feel that for the whole vehicles, it has the powertrain, chassis, or the others. So it look at the different fields. Can anyone answer this question? Okay. Yes, I will have a trigger provided here. So I believe that for the cost and the technology, this is two sides of one coin. If we dream about a technology to cut the cost by half overnight, well, I don't think there is a disruptive technologies like that. In the past 20 years, if we talk about the disruptive technology, that is maybe the EE architecture, the fundamental changes on the architecture that is from Tesla. Or we say software-defined vehicles. And autonomous driving may also be promising, but still there is a long way to go. So for the current cost-down solution, we believe that it is about the scale. To have the rational technology combination satisfy the expectation of the users and to scale up and reach the synergy and get the cost down. Like a Model T, this is not a technology innovation, it is a process innovation. So that is a change of the production line. It changes the way of the assembly. So you mentioned whether or not we can have the technology to realize a disruptive result. We believe that in the short run, at least in the foreseeable future, we don't see this. So I think maybe the scaled effect will be more promising. So please get the microphone. There is a feedback. So please also introduce yourself. Good afternoon. My name is Nie Yong. I am from Aishan Technology. And we have two projects. One is the Metaverse industry platform. Another is the vehicle supermarket platform. One is for the product sales. Another is for the supply chain technology service. So talking about the cost down, my two platforms can be of some help for the supply chain. As mentioned by Mr. Shen, we need a scaled economy and a scaled effect to help with the cost down. Another is the Metaverse vehicle supermarket, and it can sell for the different brands and for the aftermarket. So this is the online showroom, and we also have the offline platform. Well, yeah, I think this is a commercial. Yeah, I know this can cost down. The platform can also do the cost down. We can talk about it offline. So now let's focus on the technology part. Do we have other speakers or questions? If you don't answer, if you don't ask questions, and we have to let Mr. Zhu leave. Okay, now we move on. So for the cost down, this is a very big topic looking at the different fields. The cost down and the light weighting are the ongoing topics in the industry. So we need the technology progress. We also need the new technology. When the technology is coming up, initially the cost is higher. But when we have the scaled economy, we will see the cost will be lowered. Okay, thank you very much. And now we move on to Dongfeng Research Academy. Let's welcome Mr. Yang Yanding, the head of Dongfeng Research Academy. So I am very honored to participate in the 6th Global Auto Technology Leaders Summit. And many thanks to CAAM for building such a platform and to be of a lot of help for the auto industry's future development. And we also have seen that this is a good platform for us to have wonderful exchanges and to look at the future development of the industry. So many thanks to the organizers. As mentioned by Mr. Fu, in the past 10 years, we have done a lot of endeavor. In that 10 years, I feel that this is 10 years of accelerated development. And we have the luck to witness the fast development of the industry, including the NEV and the strategic development. And also, I feel that I'm very lucky to be a part of this transformation and make contribution to this transformation. And also, I feel that in these 10 years as a R&D people, I feel that on the one hand, this is also extremely difficult 10 years, especially for the R&D. We work overtime every day, try to shorten the lead time, the development cycle shortened from 36 months to 24 months, and the next is 16 months. This is really a big challenge for all the R&D people. And second is technology development is really swift. So we see the fast development in all the different fields. And we also see this is an increasingly multidisciplinary professional field. You have to learn new things every day. So first, I specialize in chassis, and then I look at the whole vehicle, and now I look at IT. So if you stop learning, you will be lagged behind. And I also feel that we are very lucky because we are in the unprecedented wave. And in this period, we can grow together with the industry. And we experience a lot of unprecedented changes and growth. And I feel that we are lucky to get this period. And also, in the NEV development, and the advantages in the new track is very precious for China. And we are very lucky because we get the opportunity in this field. Can we continue this advantage? This is a question in front of us. So I want to also, based on my experience, and talk about the ACES, like connectivity, electrification, low carbon, and globalization. For the R&D, I may focus more on the electrification and low carbon. And to share with you what we have been doing in Dongfeng.
这个电动化的这个视角来看，中国的这个因为电动化我们已经取得了很大的这个成绩啊。目前来讲的话，我们的这个整个这个电动化技术，包括这个产业链，应该说已经是非常成熟啊。那么未来在电动化方面，我们应该在哪些方面去创新呢？我觉得刚才这个我们朱总讲。
how to make innovation, and because we already have these requirements, because we already feel it very strongly, because in the systematic way, such as the electric driven, and we have been good enough, but what other aspects we need to do more? And actually, a lot of work need to be refined and deepened. And for example, and we have from the coil engine, and we have a better efficiency, and we have a smaller size of the motor and the rotator technology, and it is in a fast speed. And at present, the electric motor has been good enough. But in the future, what the other technologies, and from the 8 layers to 10 layers, and whether we are going to have more laminations in the flat wire motor, and there are many, and some of them use the excitation line and to coil up, and so that the copper utilization is higher, and so that we could further lower the cost and to improve, such as the Tesla in the early stage, and in the rotator it uses carbon fiber to have realized a better RPM, and we need to refine our work, and we can have more technological innovation. And the other one, like we mentioned, and the leader from Toyota already mentioned this hybrid technology. I should say that in the engine heat efficiency, and also the hybrid engine behind it, and how to generate more power, and so that it can be better adaptive to the hybrid. And behind it is about how to increase the heat efficiency, and to further refine the structure, and so that with less, that the hybrid technology have less working nodes, and how to sustain the optimization, and all of which are our future direction. The other thing is the system, and we need to think about technological integration, and also the wire control, and also electrification integration, and in the future, and it is about the nanosecond control. And I think that it is quite good, and to have a better performance. And just now we have, I want to share this with you, in developing Mengshi, in order to, because they want to overcome the trap in the sand, because it is a sand flushing. There might be a flying up and also going down, and in landing, and the vehicles, the wheels in front spinning, big impact on the system. And we have refined it by the refined control, and we can realize the higher performance. So, and there might be some refinery work. That is about electrification, intelligent development. I quite agree, and I think that the foundation for intelligence is the such as at Dongfeng, we have a centralized, aggregated architecture, and in the future, we're on the whole platform of the group. And it lays a very solid foundation, and based on that, and we can have end-to-end autonomous driving. And also, we haven't talked about V2X integration, and also, and in the future, and a single vehicle intelligence, and also it will become. It is one of the reasons, and we are able to keep it as our advantage. And the low carbon development, just now we have shared it, And we really need to go deep into the material, the whole life cycle, the carbon emission, material innovation. There is a very high level of value and significance. For example, integrated casting and also the die casting, and also the hydrogen technology and the net zero, near zero emission. And we are making active exploration. And in order to realize in the next turning points, we need to seize the opportunity. The other thing is about institutional design, and we have a emerging productivity. We need to have a new type of production relationship, and we need to reform the structure. We need to have the talents to enable this process. Thank you. Thank you, Director Yang, for your sharing. And Mr. He, maybe we have Mr. Shen to make the presentation first because he is leaving soon. And I'm sorry, I'm jumped the queue because the colleague asked this question on cost. I just follow this question. So I think that's this is a very timely organized forum, and I should say, whenever we talked about electrification and intelligence, people often talked about competition, and many media friends become technical experts. So we talked about all kinds of live streaming, and the board chairmen become the drivers. So that is the pace. However, we still believe if we think about it, and Mr. Yang and others talked about, and 24 months or 36 months and others, but down to earth, and China in the past 20 years. And in the electrification, we have achieved unprecedented achievements, not mentioned by us, but also acknowledged by Europe. You know, Europe is not competing with us, and they remove these and a lot of vehicles exported. And all these are the truths in front of us. And now, I think the electrification, we often talked about it, is about the upper part of this electrification coming to an end. And the second half is about intelligent development. And it is not 100% like this. And I think that it is the first part. And the second half, we still have a long journey. And if we look at the whole process, just like we talked about sales and security, which is our belief, and in Geely, we think the safety and the security is our bottom line. It is the same. And we still believe that the vehicle as a commodity, it is about safety, and that is the fundamental thing. And we have a lot of technical experts, and who can say that the battery is 100% safe. I believe no one can say so. Therefore, in the coming 3 years, and Mr. Wu Kai already living, you know, even him cannot say 100% because that is the physical rules. And in the coming 3 years, and also in the liquid battery, and I believe they have integration, system, control, and other ways. For example, lithium iron phosphate battery, and to make it possible. And we are working on similar things. And Geely has carried out a lot of work. For example, we have a lot of and difficult to say, and anyone have made breakthroughs, and we have a higher integration, and also we have a better monitoring, and we think about its monitoring and alerting system, and with a refined development and refined testing.
现实应用中的大量的情况。
And
所以呢，通过这些手段，我们做到了我们的电池。
And we need to think about that the batteries. And the next step, there are two things. And Mr. Wu Kai already mentioned. One is the battery replacement. A lot of high density and high charging efficiency. And I cannot say they are 100. They are compulsory to each other.
换电其实是一个方面。那行业内也有大量的企业在布局。
And we have a lot of people and in making presence and in a lot of work to be done. And at present, the other thing, and many of you could do it together, that is the standards, the battery modes. And sometimes they are not aligned with each other. And whenever we talk about number 5, number 7 batteries, people know it very well. And I shall say it is. And we could think about it together in the competition. It's about the second, the future. And the other thing is that the solid battery development. And we often add this, the full solid state battery. And even if it is not a full solid state, we just call it a solid state. And people would come to these news. A lot of them would mention, and some of them, and you know that, and we are catching up, and we are working together, and if it is possible, that we want to enable with each other, and we are able. I think that is the second half of the electrification, intelligence such as intelligent cockpit, and also Mr. Jiang is still here, and the 7 nanometers has been available and enabled the whole industry. And also and AD 1000, and it will be available in 2026. And I think it is still in this process. How could we enable each other with the technology? I believe Mr. Fu want to say this. We work together, and we want to say, and how we could share this together. And the other thing is about cost, and the cost is about the scale. And of course, there might be some technology which will bring the cost down. And on one hand, we talked about electrification. What is the core of it? And I believe the national strategy. There are two things. And first of all, and the zero emission. So these are the two things. And in the fuel cars, and the 3%, and the oils are imported. 70%, all of them, and 70% of the oil consumed by the vehicles, and the people know it, and therefore, after using the battery, and to some degree, we know that at present, in the existing technology of China, every 1 kilowatt hour, it is due 600 gram carbon dioxide emission. And Mr. Zhu and the colleague from Toyota mentioned this. We work on hybrid as long as you have the right engine. But how to address the emission issue? And therefore, there is something that is about zero carbon fuel. And not long ago in Japan, there is a carbon neutrality, and together with others, and Europe is promoting e-fuel, and even though, and in 2035, and the e-fuel which is good for the IEC. Why we mention this? Because China, I mentioned the electrification in China has made a lot of progress.
So this is only in the passenger vehicles. For the commercial vehicles in China, especially for the heavy-duty trucks, the total ownership is only 11% of our total vehicles. But when we look at the emission, that is 56% of the total emission. And with the carbon neutrality commitment, how to realize the carbon neutrality, this is a big challenge in front of us. So, for the internal combustion engines, we have to deal with the CO2. And I feel that we can do the recycling of the CO2. So we change it to the methanol. The methanol is e-fuel. And in February 2023, we have realized the mass production of the technology. And this is the first and the largest low-carbon methanol facility, and this is successfully used on the torque of the Asian game as the fuel of that. So for the internal combustion engine using methanol and have it work together with the engine and to realize the zero emission. This can lower the cost and improve the fun of driving. So I believe that the new energy competition, the second half of the competition, will look at the zero carbon solution. Thank you. Thank you very much. So we know that the OEMs, they are trying to use the most appropriate technology and find the solutions. And we know that zero carbon is the next generation. And also I would like to thank Mr. Shen for this great inspiration. And you also mentioned the electric consumption for the 100 kilometers. Currently, our requirement is for 12 kilowatt hours. That is, for 1 kilowatt hours, it should support the range of 10 kilometers. And for the CO2, it is 600 grams. So you will see that there is still a big difficulties for us to overcome. So this is for the current